Hi guys, welcome back to my channel. So yeah, as I promised you guys, so today we're gonna be looking at some past exam papers, on those number patterns that we've learned. So yeah, we're gonna look at November 2021 and November 2020 paper, and then yeah, see how we can apply the concepts we have learned, right? Yeah, let's get to it. I'm just going to share my screen and then we can start. Okay. Okay, so so this paper is like November 2021. So the number pattern questions, they were starting on question 2. So yeah, let's see what the question was asking. So the question was saying that yeah, you are given a geometric series which has those 3 terms, right? So remember, series is a summation. It's like a sum of n terms. Like when they talk about series, they talk about sum of n terms, essentially. So yeah, the first question wanted us to calculate the value of x, right? But yeah, before we get to the actual questions, I want you to start thinking about some of the characteristics of the geometric sequence that you've learned, right? So as soon as the question tells you that this is a geometric series, so in your mind, you should be thinking about all those concepts that you've learned, like, the constant ratio between consecutive terms, the Tn formula, and then Sn formula for geometric series, and as sum to infinity formula. Right? You should be having those in your mind so that you can easily answer the question once they ask you anything about those, right? Okay, so yeah, let's look at the first question. So the first question asks, determine the value of x. So x is the first term in that sequence, right? So yeah, for us to derive the value of x, we need to use the characteristics of what? Of a geometric series. If you are thinking constant ratio between consecutive terms, you're definitely on the right track. So what we need to do is to realize that, so if you take T2, right, over T1, it must give us the same answer as taking what, T3 over T2, right? And that, like, you can just call it R, which is the constant ratio that you expect, right? So if we use these, so then we're going to say 90 over X must give us the same answer as 81 over 90, right? So yeah, from here we just need to cross multiply. If we cross multiply, so we're going to get 100 is equals to 81x. So therefore, this implies that x equals to 100. So essentially, we're going to take 8100 divided by 81. That's equals to 100. Okay. So like there we go. So like we already have answer for first question, right? So this is equals to 100. Simple as that, right? So let's look at the second question. So the second question was saying, show that the sum of n terms for geometric series, or for this geometric series, can be written in that format, right? So the first step is to remember the geometric series Sn formula that we've learned. The formula for geometric series, remember I said there are 2 formulas, but in this case I'll use the one that I shared with you. So we know that Sn formula for geometric series is Sn equals to A, open bracket, R to the power of n minus 1 over R minus 1, right? So that's the geometric formula. Geometric series formula, or sum of n terms that we've learned, right? So yeah, in this formula, we need to know the value for what? We need to come up with the value for A and then the value for R, right? So in our sequence, remember we said A is the value of the first term all the time, right? So what's the first term there? The first term is X, which is 100 that we've identified. So this guy then is equals to the 100, right? And then a ratio, how are we going to get R? So R is the ratio between like the consecutive terms. So R is going to be 90 over 100 or 81 over 90, like whichever that you choose to use. So that's 0.9, right? Okay, so then now if we continue to substitute there, so if we substitute in our formula, so we're gonna have A, which is 100, and then you're gonna have R to the power of n. So what is R? R is 0.9 of n minus 1, then divide by what? What is R? 0.9 minus 1, right? So yeah, this is the same as what? This is the same as, remember 0.9 minus 1, so that's like minus 0.1. So I'm just going to write here, so minus 0.1 is the same as minus 1 over 10, essentially. So, and then if we're going to be dividing by fraction in the denominator, then this is the same as multiplying the numerator by what? By the denominator of that fraction. So in this case, it's the same as multiplying by minus 10, right? So this is simplifies to minus 10 multiply 100 and then 0.9 at the power of n minus 1, essentially. So we killed that denominator because it's just like multiplying at the numerator, right? So yeah, then this simplifies. So if you multiply inside the bracket, so we're gonna get just trying to make a room. So yeah, we're gonna get if we multiply inside the bracket, so we're gonna get minus 1,000, right? It's the same as 0.9 to the power of n minus 1. Okay, so then now the next step is just multiply inside the brackets by -1. Therefore, the final answer will be 1,001. Remember, if you multiply by, it's going to be positive 1 minus 0.9. Okay, so then yeah, that should be the answer that they're looking for. That's the answer that they're looking for. So if you look here, yes, that's the answer that they're looking for. Simple as that. So now you have proved that, you know, the sum of n terms for this series can be written in that form. Okay. Okay, so the last question was asking you to determine sum to affinity, right? Sum to infinity. Remember, we have also discussed this. We discussed the formula for sum to infinity. So if you don't remember the formula, you'll be in trouble. Okay, yeah, but anyway, so you can just quickly refer into your notes. If like you forgot the formula, just refer to the first video where we covered this. Okay, so sum to infinity. So sum to infinity for geometric series, we know that that's a over 1 minus r, right? Okay, so we already know what a is. So a is 100. Remember, a is x, which is 100. And then our ratio is 0.9, right? So this simplifies to 100 over 0.1. So that's the same as what? 100 multiplied by 10. That's like 1,000. Yeah, simple as that. So that's the formula for that's the answer for 2.3. And then yeah, so you'll have your 3 marks essentially. Just as simple as that, because you know this question was just straightforward application. So if you knew your formulas, if you knew your formulas, and then like you knew how to apply, then you will have gotten your 6 marks. Simple as that. Okay, so let's look at the second question. So the second question was saying that consider a quadratic number pattern. Minus 145, minus 1, minus 1 over 1. So they already told you this is a quadratic number pattern. So at the back of your mind, you should be thinking a second difference of this sequence should be constant, and the first difference of this sequence is what this arithmetic sequence, right? And also another important thing that I want to mention is that, like, don't isolate some of the properties that you learn for quadratic functions on the functions chapter on, like, with the number patterns, because like some of the concepts that you learn from quadratic functions, they can be useful in answering some of the questions on the quadratic number pattern. So yeah, just keep in mind those characteristics as well, right? Or properties that you've learned. Okay. So let's look at the first question. So the first question was saying determine the value for T4. That's the fourth term in this sequence. And then the second question said come up with a general term formula, right? So Tn formula. So yeah, I'm just going to open a whiteboard so that I can have some room to answer this question with you guys. So give me a second. So, open a whiteboard. Okay, so the sequence that they gave us is -1, 4, 5, -1, 2, 2, -1, 1. And then they want us to determine the value for x, right? So x is like the fourth term, which is T4. They want you to determine the value for T4. But we know that for quadratic sequence, we know that if we take these differences, right? So if you take this minus this, that's 23, and this minus this, that's 21, I think. And then x minus, that's gonna be x minus 101. So that's gonna be x plus 101. Please make sure that you don't mess up with the signs, right? Because like you have to be careful that you're minusing with the negative numbers, right? So it's like -122 minus. So it's the same as -122 plus 145. So just don't mess up with the signs, right? Okay. So then we know that the second difference for this sequence, like it has to be constant. That's one of the characteristics of quadratic number pattern. We know that this has to be constant. So if we take this minus this gives us -2. And then this has to also give us -2 because it's the characteristics of what? Of quadratic number pattern. So if this is a second, if this second difference is -2, then which means then to get to this -2, like if we take this guy minus this, it has to give us -2. So we can solve for what? You can solve for x by actually saying that x plus 101, if we minus 21, that should give us -2, right? Essentially, because that's how you get these differences. So if you solve these, so if you just write it neatly, so if we solve for that, okay, so let's just take it to here. Let's take this here. Okay, so essentially, so you're gonna have like 101, so 101 there. So let's just simplify that. So you take everything to the left. So you're gonna have x equals 2. So on the left you have -2 plus, so 21 when you take it to the other side, it's gonna be plus 21. And then 101 is gonna be -101, right? -101. So yeah, then your x is gonna be, so if you just punch in a calculator, I think it's gonna give you -82. So let's just see. Yeah, I can just quickly, so this is like -2 plus 21, that's 19. So 19 plus 101, that should be 82. Yeah, so you can just confirm in a calculator if you're not sure. So I'm also just verifying. Yes, that's 82. So then, yeah, which means the fourth term then in that sequence is that is equals to, -82. Okay. So then, yeah, that answers the first question. That they ask us. So we know that the first term, I mean the T4, that's equals to -82. Okay, so the second question said, like, yeah, let's determine Tn formula for this quadratic sequence. So let's open the whiteboard again. So what's the TN formula? So TN formula for quadratic sequence, what's the formula? Remember? So Tn equals to an squared, right? Plus bn plus c, right? So yeah, we need to derive the values for a, for b, for c, for us to get to that answer, right? So essentially, remember those equations that we've discussed. So we discussed that 3 equations that you need to solve for us to solve, for us to solve the Tn formula, right? So the first equation is 2a mass equals to the second difference, right? The second difference in the sequence. The second difference. Yeah, 2a mass equals, that's like you can see equation 1. And then second equation is 3a plus b mass equals to the first term of what? First difference. Okay, that can be equation 2. And then the third equation to solve for is a plus b plus c must equals to the first term of the sequence. Okay, so then now we just need to solve those equations, right? We just need to solve those equations. So what's like the second difference? If you forgot, let's go back. So that's -2, right? So -2 is the second difference of that sequence, right? Which is constant that we expected. So then we're going to equate -2 to 2a to solve this equation. So as you can see, this implies that a equals to -1. Okay, so we already have a now. We will solve for a. So we solve for a, which we're going to have to substitute here. And then now we're trying to solve for b, right? So to solve for b, we need to know the first term of the first difference. Let's go back. So the first term of the first difference, that's 23. 23 is the first term. It's the first term of the first difference, right? Okay, so if we go back, so which means then you're going to have to equate this guy. We're going to equate this guy to 23, right, to solve it. So we're going to have 3. What's a? A is -1, you substitute there. And then plus b. B is what we're looking for. That's mass equals to 23, right? So then if we solve for b, we make b subject of the formula. So b is going to equals to 23. So you take -3 from the left to the other side. So that's going to be 3. Then which means 23 plus 3, that's 26. Okay. So now we have what? Now we have a b, which we need to substitute here, and then substitute a as well here. And then now we solve for what? We solve for c. But how we get c? So c, we need to know the first term of the sequence, because we're going to equate everything to that, which is -145. So if you go back, so that's going to be -1 plus 26 plus c must give us -145, right? So -1 plus 26, that's 25. So you take 25 to the other side. So it's going to be negative. So it's going to have c equals to -145 minus 25. That's equals to, so -145 plus -140. So I mean plus -25. So that give you -70. Okay, so then that means then our Tn formula, since we have c as well. So we have c, then Tn formula is going to be, what's a? -1 n squared. What's b? Plus 26. So that's 26 n. And then what's c? -170. So that's the final Tn formula. That's the final Tn formula that we're gonna get. Okay, so then now we just need to check if this answer that we have is consistent with what they ask you to prove, right? So let's go check. So if we check what they ask us to prove, so yes, that's correct, right? That's correct. Our answer is correct. So that's Tn formula for that quadratic number pattern. Okay, so then now the second question I was saying, between which two terms of the quadratic number pattern will the difference be of minus 121? So you have two number patterns. I mean, between which two terms, if you take the difference between those two terms, you get minus 121. So the easiest way of doing this, so is to think of it this way. So if we have two consecutive terms, if you take the difference of that, should give us minus 21. So solve for those terms. So if we take, let's say, we don't know like what are those terms, right? So if like, let's say we just say hypothetically, so hypothetically, if we take, so if we take, let's say, so if we take Tn plus 1 minus Tn, they must give us minus 121. So if you take the difference of those two terms, they should give us that. Right? So now we just need to solve for n, because if we know n, then we know, okay, between this term and this is where we get that, right? So let's try to solve for n using our Tn formula. Okay, I'm just going to open a whiteboard. So, okay, let's see. So we have, okay, so we have Tn plus 1 minus Tn must give us minus 121. And then what's the Tn formula? Remember Tn formula. Let's just write it on the side so that you remember Tn formula is equals to minus n squared plus 26n minus 170. That's Tn formula. So that's what we're going to be substituting into, right? Okay, so then to solve this equation, therefore we're going to be, okay, so you're going to have a minus n plus 1 squared plus 26 n plus 1 minus 170, right? Minus, let's just change the color. So that's going to be the same as minus n squared plus 26 n minus 170. So that must equals to minus 121. Okay, left hand side must equal to the right hand side. So now we just need to simplify the left hand side to make it a little bit neater. So if we expand the brackets, so I'm just going to do it in my head. So, but yeah, if multiply out, then you're going to have minus, okay, let's use the same color. You're going to have minus n squared. So minus 2n minus 1 plus 26n plus 26 minus 170, right? Okay, so let's also multiply the bracket for, yeah, let's also multiply the bracket for this one. So if you multiply negative, so that gives you negative, no, it gives you plus n squared, and then you multiply minus 26n plus 170 must equals to minus 121. Okay, so now let's look for the terms that they cancel each other out. So let's look for the terms that they cancel each other out, the like terms, right? So this guy will cancel with this one, and then so if you look at this guy, will cancel with this one, and then this guy will cancel with this one, right? So which means you're only left with 3 terms. You're only left with 3 terms, which is this guy, and this guy. That's what you're left with. Everything else cancel out, right? Of course, like you equate that to the right hand side number. Like. So if you simplify this, so you're gonna have minus 2n minus 1 plus 26, that's plus 25. Then we have minus 121. Okay, so if we simplify these, so we can take this guy to the left, I mean to the right. So if we take this guy to the right, so then you're gonna have minus 2n equals to minus 121 plus, I mean minus 25, because when it goes to the other side, it's gonna be negatives, then it's gonna minus 21 minus 25, that's minus 146. Okay, so then if we simplify this, so we get minus 2n equals to minus, okay, you can just kill this step here just to solve for final answer. Yeah, so essentially, so the answer then is gonna be, the answer will be, so n will equals to minus 146 divided by minus 2, right? So that's the same as 73. Okay, so then this means that that n is 73. So which means if we go substitute n into our equation here, right, into the, so which means then between T73 and 74, like, because if n plus 1 is going to be 74, so between T74 and T73, yeah, between those two, that's where, yeah, that's where if you take the difference, then you get what? You get minus 1, 2. Okay, so then that answers the question, right? That answers the question. So if we just go back, so the answer there is between between T73 and T74. That's where, like, you get the answer for that. Okay, so the last question was saying that what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1. So let's be careful here. So they say what value must be added to each term in a number pattern so that the value of the maximum term in the new number pattern will equals to 1. Okay, so let's try to translate this into maths of what they're saying there. So they're saying that so currently you have Tn, right? You have Tn for me. So they say they're transforming this guy into some Tn star. Let's call it Tn star. So what is this Tn star? So this Tn star is Tn plus x, right? So x is what you're trying to solve for. So we want to solve for x. But how do we solve for x? X must be solved such that the maximum, okay, let's say such that, right? So the maximum of Tn star must equals to 1, right? So how do you get the maximum for Tn star? So the maximum for Tn star, so that's the same as maximum for Tn plus x must equals to 1. So essentially, this means that if we can solve for maximum for Tn, which is our original number pattern, and then we add x, we can solve for unknown, which is x, right? So how do we get maximum for Tn? Remember what I said? Like, we need to remember some of the characteristics of quadratic functions that can help us to solve some of these questions. So we know that in a quadratic function, if you have f of x, right? So to get the maximum of f of x, so firstly, we determine what the x value of a turning point and substitute it into that. So x value of turning point is minus b. So minus b over 2a. So once you have that x of turning point, if you substitute that, right? So if you just say xt, so f of xt, so that's essentially what your maximum, essentially. So if you think about it, so you have a graph that looks like this, right? So this is the turning point. So this is xt. Then yeah, this is the maximum. So yeah, for us to get that maximum, we need to substitute this guy into the function. Okay, so let's see. So in this case, f of x, that's gonna be Tn formula, right? Tn formula, that's the f of x that we're working with. So let's try to solve the maximum. So remember, Tn formula is equals to minus n squared plus 26 n minus 170. So now we're trying to find the x turning point for this function, right? So to get that, you're gonna be, so x is gonna, okay, let's not say xn, because n is the variable in this case, x is not variable. I was just using X so that, you know, you can draw a parallel between the functions and this. Yeah, this is gonna be, okay, let's just erase this guy. So this is gonna be, so X is gonna be, actually, why am I writing X again? So N is gonna, so I'll take that call. So N is gonna be, minus, what, minus B over 2A. Yeah, what is B? B is 26, right? And then we substitute A, what's A? Minus 1 from here, right? So, okay, so then you have what? You have minus 26 over minus 2, that's 13. Okay, so if you have n equals to 13, which is like a sort of n that maximizes Tn formula, then if you substitute T13 into this, so which means then T13 plus x must equals to 1, right? So which means x then equals to the x equals to 1 minus T13. What's the value for T13? So that we need to substitute into our Tn formula. So T13, that's gonna equals to minus 13 squared, right? And then plus 26 minus 13, sorry, 13, not minus 13, 13, okay. And then, so then we minus 170. Okay. So minus 170. Okay, so that's gonna equals to, yeah, let's try to do quick maths. So that's minus 1. Okay, so then which means then if we substitute here, x is gonna be 1 minus 1, and that's equals to 2. Okay, so which means then if we add x equals to 2 into our original sequence, if we add x equals to 2 into original sequence, then that will make sure that, you know, this condition is met. This will make sure that this condition is met. This condition is met. Okay. Yeah, okay. So then now I think that solves the question, right? That solves the question. So now we can look into the last question. So here we know that x must equals to 2, right? That's what we should add. Okay, so the last question, yeah, the last question was saying that consider linear pattern. Linear pattern. Remember, the linear pattern is the same as what? It's the same as arithmetic sequence. So linear pattern is the same as arithmetic sequence. So so yeah, as I said, like every time you answer this question, you should be thinking at the back of your mind that, you know, what did you learn that can help you to solve these questions. So you know that, you know, for linear sequence, the difference between consecutive terms should be constant, and then also remember those Tn formulas and Sn formulas, right? Okay, so yeah, so okay, so then now the first question was saying that determine the value for T51. So T51 is the 51th term, right? So yeah, obviously, I mean, you're not gonna be doing this by adding constants all the way to up to T51. So the easiest way of doing this is firstly to derive Tn formula, and then once you have Tn formula, then you can substitute n for 51, and then you get the answer, right? Okay, so let's see how we can do that. So what's the Tn formula? So Tn formula equals to A plus n minus 1 d, right? Okay, so if we substitute, we need to substitute for A and D, right? So what is A? A, remember, is always the first term in the sequence, right? So always the first term in the sequence, and D is the common difference. So if you look at these guys, so the common difference is 2, 7 minus 5, 9 minus 7. Okay, so then if we substitute here, so that's gonna be 5 plus n minus 1, and then what's d2? And then if you solve for that, so we get what? We get 2n minus 2. Minus 2 plus 5, that's 3. So we have 2n plus 3. That's equals to what? That's equals to Tn formula, right? So then we just need to substitute. We need to substitute T51, so which is the same as 251 plus 3, right? So then T51 plus 3, so that's gonna be 102 plus 3, that's 105. Okay, so that's the term number 4, term number 51. Okay. So yeah, then the second question was saying we need to determine the sum of what? The sum of n terms. The sum of n terms the sum of 51 terms, sorry. The sum of the first 51 term. So you should be remembering SN formula as well, because that's what you're gonna need to use for this question. So yeah, let's write down the SN formula. So the SN formula equals to n over 2, 2a plus n minus 1 d, right? Okay, so if we substitute so S51, so that's the same as, so if we substitute, so it's going to be 51 over 2. Remember, A is 5, 2 times 5, and then plus n is 51 minus 1. What is D? D is 2, remember? Okay, then you just simplify this. So if you simplify this, so you're going to have 51 over 2. And then inside the bracket, you're going to have 2 times 5, that's 10. And then here's 51 minus 1, that's 50. 50 times 2, that's 100. 100 plus 10, that's 110. So 110. So then that means then your answer should be 51 times 55, right? So you can just, you don't need to simplify to this. I'm just trying to do it in my head. That's why I'm doing this. Yeah, so at this point, you can just punch your calculator and get the final answer, right? So which I think is 2805. Let's just try to confirm. 51 times 55. Yes, okay, that's correct. Okay, so then then that solves the first two equations. So then now we have we have the third question there that says derive. Okay, they say write down the expansion for Sn for that sequence that they gave you there. So let's just erase here. They say write down the expansion for this. Show only the first three terms and the last term of the expansion. Okay, so I'm not sure if you are very familiar with what this notation means, this sigma notation. So this essentially, when you see this, it just means sum, right? Sum of something. So usually it's sum of Tn formula. So here they'll put Tn formula. So which means you will be summing a Tn formula up to starting from the lower index, which is starting from 1 up until 5,000. So in this case, you're going to substitute n for 1 there, and then you get the first term. You repeat up until 5,000, right? So that's essentially what it means. You're adding those terms up to that point, right? Okay, so in this case, they say show expansion of this, for first three terms. So they already gave us the first three terms in this sequence. Can you see that? Right. So if you substitute n equals to 1, you're gonna get what? You're gonna get 5. Substitute n equals to 2, you're gonna get what? 7. Substitute the n equals to 3, you're gonna get 9. So essentially this means that you already have the first row sequence, which is 5. So 5 plus 7 plus 9, right? So then we need to add the last term, like the last term here, which is T5000. That's the last term that you need to add, T5000, right? So to get T5000, so we just need to substitute T5000. So that's, let's say 5 plus 7 plus 9. I'm just going to circle the 10 so that you don't get confused. Okay, so T5000. So that's like, if you substitute 5,000 for n there into the Tn formula, that's 5,000 times 2, that's 10,000 plus 3. Then that's 10,000 and 3. Yes, that's like what the expansion that you want to see, right? Okay, yeah, then that simplifies the question. That's why like it's 1 mark, because they already gave you the first 3 terms. So all you need to do is just to get the last term, which is substituting 5,000 into n there and then simplifying the formula. Okay. So yeah, then we have the last question. We have the last question. They say hence or otherwise calculate, this guy. Okay, I'm just going to open a whiteboard to try to solve this because I'm not going to have a room. So if we open the whiteboard, so the question gave us, so we have 5,000 n equals to 1, 2n plus 3 plus n equals to 1, 4,999 minus 2n minus 1. Okay, let's just verify to make sure that we copied the formula correctly. Okay, yes, that's correct. Okay, so then they say we need to simplify that. Right? We need to simplify that. We need to simplify that. Okay, so to simplify this, so I mean, there are 2 ways of doing this. There are 2 ways of doing this. So remember, so if I just write here, so Sn n equals to 1 of Tn. So this is the same as what Sn is. This is exactly the same thing. So if you think about this, so essentially, if we can write these guys in the form of Tn's, then we can use Sn formula, right? So yeah, we can try to write these things as in the form of Tn formula for arithmetic sequence. We can try to write this in the form of what? In the form of Tn equals to a plus n minus 1 d. So if you can write them in this form, then we can be able to substitute with Sn formula, which is Sn formula, which is n over 2a plus n minus 1 d. So we can substitute this formula. But firstly, for us to do that, we need to write this in the form of this and use the advantage that we know that this means 10, right? So in this case, that would be S499, and then this one will be S5000. But for what? For the Tn's that you will have to write. Okay, so let's look at Tn here. So 2n plus 3. So 2n plus 3. So this one, remember, we already know from our function. We already know that this is the form of the form that it took, right? So remember, before we derive this formula, so you just go back. So yeah. So okay, I know we erased that. Okay. So what I was saying is that for this one, so we've already identified that the formula was so 2n plus 3 is the same as 5 plus n minus 1, 2, right? So it's already written in the form of this guy. Then you can just directly substitute what d for d in the formula for Sn there. Sorry, d in the Sn formula there, and a as 5, because we managed to write it in this form because we did. So we need to do the same thing for we need to do the same thing for Tn minus 1. So let's see. So minus Tn minus 1. So to write that in the form of these, so we're going to have to say, 2n, so which means minus 2, so you can write it as, so let's just say n minus 1 first, and then let's say minus 2 there, right? So minus 2, that's going to give minus 2n, and then minus 2 times minus 1, then that's going to give us plus 2, right? So plus 2, if we take plus 2, and then we say minus 3. Right? So then that gives us the answer that you're looking for, right? So essentially, if you expand this, so it should give you the same answer as this, right? So this minus 2n, this plus 2, minus 3, that's minus 1. So then, which means then this is gonna be our A, this is gonna be our D in this sequence. Okay, so then, yeah, we can just simply substitute those into the formula. So then we can say, okay, that expression there at the top is the same as 5,000 plus as 4999, right? Where else, like, for this one, okay, let's just say star here, so that to make sure that like these SNs are different, right? So this one will be based on this formula, then this one will be based on this formula. Okay, so if we just do that, so the answer is gonna be, we're gonna have n is gonna be 5,000 for the first one over 2. Okay, so it's gonna be 2a. What's a? A was 5 plus what's n? N minus 1. That's 5,000 minus 1. Okay, so what's the difference? The difference was 2. Right, and then we're gonna minus. For the other formula, that's gonna be 4,999 over 2. Okay, and then what was A? A was minus 3, remember? A was minus 3. Okay, so that's going to be minus 3 plus 4,999 minus 1. What was D? D was minus 2. Okay, so then, we just need to simplify those two terms. So to get to your final answer. So at this point, I'll just punch the calculator essentially, and then get the answer there. Right? So let's see what the answer is gonna be. Okay, so that's equals to 4,999 times 2. Answer. 6. Yes. Okay. Okay, so so you can just say 4,999 plus 2. Okay. Yeah, so the answer is going to be 2,000. Okay. So then that will be the final answer that you're looking for. So I think that was quite some interesting question, but it was actually simpler if you knew the meaning of the expansion of the sigmas, and also you knew your formulas, right? Okay. yeah, that brings the end to our November 2021 paper. So yeah, if you do have questions over the things that we've discussed, please let me know. I'll just try to explain it to you. And yeah, if also you want to see some more past papers or the past paper that maybe you attempted that you struggle with, please let me know. I can try to attempt it here with you. And yeah, thanks for watching, guys. Really appreciate your support. And yeah, so feel free to let me know, if you have any concerns or comments about what you want to see, because these videos, I'm doing them for you so that, you can be well prepared by the time the exams comes. And then, yeah, you also feel more confident because we will have went through the papers that were written by the past, learners. Okay. See you on the next video where we're going to be attempting in November 2020. Okay, cool. Thank you.